3, 4, 5 slices of pizza. Now my metabolism is so slow, I have one piece, I'm like, that's more than enough. It's the worst. It is seriously the worst. What's that?
I can eat
I have to stop my oldest, Marshall. Like, I have to, like, portion food out for him, or he would just keep eating. I mean, the kid's super active, don't get me wrong, but stuff. All right, what's the situation here? Is it pushing or pulling on any springs? No, so no elastic energy, right? Is it moving?
Yeah.
Yeah, so there's definitely some kinetic energy. Has it been rolling with friction? At least a little bit, so there's got to be some thermal energy, right? And then the real question is, did it go uphill some? So did it generate some gravitational energy? So what I like about this, now what I'm going to do is it hasn't rolled as far, so I'm going to have it have less thermal energy. Is that cool? Less thermal? How's that look? Does that look good? I think it looks really good. And what I like about it is now, so this potential energy concept that she mentioned earlier, it is the right concept, but we're going to call it gravitational energy because I know it has to do with the gravitational field or the gravitational forces or something. Is that cool? So gravitational energy for sure. And this is the thing that I really want to make sure you see is that in the middle here, is it moving? It is, right? But is there a bunch of gravitational energy there? Yes, there is. Cool? All right. I mean, I want to drop this ball, but this ball is a serious ball. It's a serious, this is a 2-inch, 2.5-inch steel ball bearing. If I were to drop this on you, this thing would do some serious band damage. Okay, so here's what I'm going to do. I'm going to take this ball, I'm going to hold it up like this, and I'm going to let it go. Okay? So we're going to analyze the energy from the instant that I let it go to right before it hits the ground. Is that cool? Woof! What do you notice about the speed of the ball as it falls? Does it speed up? If you drop a ball, does it speed up the whole time? Yeah, it definitely does in here. All right, so let's do this one. So I have the ball here. I just let it go. Here it's moving slow. Here it's moving faster. And here it's moving the fastest. And then this is the ground. So it's right before it hits the ground. Is that cool? So we have 4 instances, so we need 4 pi's. All right, draw them up. Let's see you fill in those pies. You guys, I love your colors. All right, all right, all right. You okay? What's going on? You okay? You up late? Up late, up early? Doing what, hanging out? What are you watching? Oh, I saw that it was on, like it just showed up, but I haven't watched any TV recently. Is it good? Obviously, to keep you up late, right? Anybody else watch tonight? Who else there?
I haven't watched it yet.
It's not watched twice.
I just saw that it showed up. Right now, I have so little time to watch TV, like almost zero. Obviously I work every day for school, and I'm working on this other project, and
I just noticed that this is the wrong set.
my children. Well, you need to do that one too. You need to do that one too. You can do the other one tomorrow if you want
I
to.
did this one already.
What?
So you probably did the original, but
I mean, yeah, I did assessment too.
yeah, you need to do 2B. 2B, B is the reassessment.
What was that called? Inertia?
Inertia?
Yeah,
Yeah, inertia.
that's what it is.
Well, inertia is okay. Are you ready?
I think so.
What's the situation in the beginning?
Gravitational energy?
Is it all gravitational?
I think so.
I do too, because it's not pushing or pulling on any springs, so there's no elastic. It's not moving, so there's no kinetic. It hasn't rubbed on any surfaces, so there's no thermal energy being generated. Could it be all gravitational energy?
Yeah.
All right, I like it. The reason that I like this unit a lot is because you get to make the decisions. Like, what do you think? Why do you think that? You kind of have to almost argue it out in your head, which is a cool thing. All right, what about the next one?
I said that like a fourth of it was kinetic energy and the rest was gravitational.
So you're saying, if I hear you correctly, you said it has less gravitational because it's fallen some,
Yes.
right? And it's moving, so it has to have something. So you're saying kinetic.
Yeah.
Okay, what do you guys think of that? Is that cool? What about the next one?
Half gravitational, half kinetic.
Okay, half. And what about this one?
I wasn't sure because I didn't know if it was like as you were catching it.
So the way the picture looks, it's not exactly quite on the ground yet, but so you could do something like, I'm gonna do a tiny little sliver of gravitational, right? But what's the rest?
Kinetic.
And if it hits the ground, right, if it's on the ground, there's no gravitational. So that looks good. What do you guys think of that? Does that look good? All right. So there's a couple other ways to do this. If you don't want to do it in colors, you can do it this way. You could say something like, all right, so diagonal this way, this is going to be the gravitational energy, and horizontal is going to be the kinetic, and then vertical could be the thermal energy, right? And what are we missing?
Elastic.
So it'd be diagonal the other direction. So you could do something like that. Or, to be honest, you could just be like, this is all gravitational energy. Oh, sorry. This is gravitational, and this is kinetic. I don't like this way as much. And this is kinetic, and this is gravitational. Or you could do the cross-hatching, or you could do the colors. Whatever you want. I want you to be, say like, I know how to diagram this thing up in a way that makes sense to me. Yes, thank you so much. How'd it go?
All right.
Good enough?
Yeah.
All right. So this is kind of a hard one. Let's see how you guys do on this one. So our initial situation, the spring is compressed and there's a block against it. You let the block go, the block starts to slide up. And here it's moving, and then the block is going to come to rest up here at the top. All right, so let me show you what that looks like. Okay, you guys see my little block? How much does this block weigh?
2 newtons.
2 newtons. You know how I know? So 2 newtons.
Yeah.
Ready? Okay? So when we look at it, I just let it go, the instant that I let it go, and then we see it's moving here in the middle, and then it's stopped up here at the top. Is that cool? So there's 3 pi's here, or three instances in location and time, so there should be 3 pi's. 1, 2, 3 pi's. Okay? Diagram it up. Fill in your color in your pies, part of the board. And then I'm going to get ready to show the announcements. And I need to practice another card trick.
See, kid. I've done all this now. I just got that vine stuck in my head where it's like, I just got a vine stuck in my head where it's like, what did you want to do? Because he was doing I'm singing it now. We all die. So I don't think he's in trouble or get killed. You're gonna love him, show you. Not hard. Welcome to Chili's, kid. Yeah. Yeah. I felt like he was trying to find it.
All right, I'm coming to see your diagrams. Let me see them.
Yeah. I don't know.
Oh my God, do it!
I'm sorry, well, it was the same one as the one I had last
It
time.
is not. It's exactly the same, only different.
It's the
It's
same.
exactly the same, only different. It's not the same if it was the.
It is. It's the grass No, it's not great.
This one's going up a ramp. So there's a gravitational, an elastic, a kinetic, and a thermal. Okay? And listen, you choose to sit as far away as you possibly can. You can sit closer.
I can't.
You can sit closer.
You're right.
Feeling good. Feeling good. So the next time we assess, you'll have to do this, right? You'll have to decide what's what. Okay? That's why we're practicing together. All right, what's my energy situation to start?
Elastic energy.
Is it all elastic?
I think so, yes.
I do too, right? It's on the spring. It's not moving. It hasn't slid against anything yet. It's at the lowest height. So I'm like, all elastic is good. All elastic. All right. What about the second one? Is there any, go ahead.
So for the second one, I was like looking back at the example state of someone with an art,
Mhm.
and it was similar to this. But I think that there's gonna be a little bit more thermal energy than we had in the first diagram, because the cart traveled farther than the block.
Yeah, I agree. I mean, I think that block rubs hard, right? So I'm gonna say a full third is the thermal energy. I think that's a very reasonable idea. What else? Is it moving?
The kinetic energy.
Yeah, there's gotta be kinetic energy, right? But has it gone up the hill?
Yes.
So what did we gain some gravitational energy?
Yeah.
All right, well then, let's do a third each. How's that? Does that seem okay?
Mhm.
And what about the last one?
Maybe half and half thermal, half gravitational.
Yikesers, look at this girl getting it done. She's like, look, it's higher up, so there has to be more gravitational energy, and it slid farther, so there has to be more thermal energy, and it's not moving, so there's no kinetic. I agree, that sounds smart to me. How's that look?